Imagine, a huge antenna receives a signal from the depths of space. Scientists check the equipment over and over again, but there's no mistake. The source really exists. Its nature still remains a mystery, and some of its features don't fit into the usual models of modern astrophysics. Why does this signal raise so many questions, and what exactly did the researchers hear? And here is the signal itself.
Just because you're not paranoid doesn't mean no one is watching you. Modern astronomers have decided not to wait for surprises from nature, so they closely monitor what is happening within the boundaries of the Milky Way and beyond. So, have there been any noteworthy discoveries? It turns out yes. Recently, the instruments detected an unidentified object that was emitting regular radio signals. It's hard to say what it is, but it clearly doesn't want to be detected. Hubble. Scientists first noticed this amazing cosmic object 2 years ago. This was made possible with one of the most sensitive instruments designed to study the distant corners of galaxies, an array of antenna grids in Australia. Remarkably, while working with this radio telescope, scientists repeatedly detected unknown objects and mysterious signals. After these inspiring discoveries, the research continued as more specific information was needed. For their work, the astrophysicists used another device called Marion from the Parkes Observatory. Unfortunately, it did not live up to expectations. No new data was obtained. Progress has only been made this year. The South African radio telescope Meerkat confirmed that the previously detected object does indeed exist, and in April, further evidence was provided by the ATCA instrument. The unexpected discovery is of great scientific value because before this it was virtually impossible to get a clearer understanding of the mysterious object. It was as if it was avoiding being observed. Monitoring showed that it simply wasn't present in either the radio data archives or in studies based on X-ray or infrared methods. What do we know about this phenomenon at the moment? It was given the name GCRT J1745-3009. Researchers characterized the object as a transient radio signal coming from the center of the galaxy. The available astronomical data cannot shed light on the origin and structure of multi-wavelength objects similar to the one discovered. Simply put, this radio signal is unique in its characteristics. Most likely in the future, GCRT J1745 DPHIS 3009 will be placed in a new class of cosmic objects and may not be its only representative. This is because, with more advanced technology, scientists will continue to detect identical radio signals. What is remarkable about GCRT J1745-3009? The radio waves it emits are quite unusual. Their duration ranges from 2 to 4 weeks, and at the end of this period, the signal stops. But after some time, it appears again. The phenomenon can be compared to blinking. Circular linear distortions are also noticeable, which means obviously we are dealing with signal polarization. During the study of the strange object, the devices picked up signals exactly 13 times. At the same time, scientists emphasize that we still cannot determine exactly where these messages are coming from. The only thing that is known for sure is that it is not a pulsar with a powerful magnetic field. Initially, the theory seemed quite plausible, but further research disproved it. So, what are we dealing with? It is known that objects in the universe differ from each other by the length of their radio waves. The stars of some binary systems are located close to each other. If GCRT J1745309 were one of these celestial bodies, scientists would have been able to detect it much earlier. Also, the object cannot be classified as a supernova since their properties are completely different. Therefore, the question of classification remains open for now. Space is an unpredictable place, and in recent years, a number of very unusual things have been found there. For example, the Hubble telescope recently took pictures of a region of a nebula called Herbig-Haro, specifically one of its objects, HH 101. It was captured by cameras sensitive to a wide range of wavelengths. The formation of the Herbig-Haro region was facilitated by young, highly active stars that sometimes emit ionized gases with very high temperatures. As a result, atoms lose their electrons and become electrically charged. What happens next? The ionized gas crashes into interstellar clouds made up of other gases and small particles. These processes occur near young stars and are characterized by incredible speeds. What does analyzing the information we've gathered tell us? Thus, scientists were able to find out how the region of Herbig-Haro objects originated, as well as record phenomena whose lifespan is extremely short, only a couple of thousand years. If you study images of such nebulae closely, you can notice how they move through gas clouds at tremendous speed, moving away from the main star. Significant changes are observed in these areas over several years. For example, in certain locations, the brightness is much higher than in other areas. One of the Hubble telescope's cameras has high sensitivity, so it is able to detect even small waves that are not visible to the naked eye. As you know, there are high brightness objects in Herbig-Haro, but it's difficult to track the processes on them because the view is obscured by an impenetrable dusty haze. This is where the WFC-3 camera, which is installed on Hubble, comes into play. It captures waves that are able to penetrate through layers of dust. However, research is ongoing, so it's too early to draw any conclusions. These are far from the only surprises scientists have encountered in recent years. The cherry on top is the next piece of news that has come from the depths of space. In 2019, the first image of the boundaries of a supermassive black hole was obtained by the New Horizons telescope. It is known that the object is located 3 million light-years away from us in the giant elliptical galaxy M87. Since the black hole photographs were obtained, scientists have become even more active in conducting research. Can we reconstruct the chronology of events? 92 days after observations began, the much-discussed, though rather blurry photo of the black hole was captured. But landmark discoveries do not end there. Astronomers were able to obtain an image of the polarized radiation of the accretion disk. After carefully studying the data, the researchers gained a clearer understanding of what happens to the magnetic field in the vicinity of the black hole. The information obtained is much more significant than the image of the black hole itself. After all, no one has ever gotten this close to it before. It was this unique data that made it possible to examine the process of accretion of objects in more detail. For example, recently, astrophysicists received valuable information from several research groups. The information concerned a powerful jet streaming out from the core of a black hole. Scientists still cannot fully understand what is happening, but this allows them to adjust existing theories. But let's set aside the dry scientific theories. What does this information mean for the average person? It was previously believed that the probability of such a huge active black hole forming near the Milky Way was extremely low, but it still happened. Moreover, near M87, there is a distinct jet aligned with the black hole's axis of rotation. This forces scientists to ask the question, do the properties of black hole magnetic fields differ? Or is it all due to an error caused by optical effects that actually turn the unstoppable stream invisible? And that's far from all the amazing discoveries awaiting us as we explore space. Who knows, maybe right now in a neighboring galaxy, There are phenomena occurring that will one day radically change
Жизнь человечества.
our planet. I want to start this episode with a phrase that begins every fairy tale. A long time ago, 44 years ago, this amazing story happened. That would all be well and good, but in our story there won't be a drop of magic, only reliable facts and real events. So, in the distant past, as we know, the Americans launched a project called Voyager 1. As part of it, 2 probes with the same name were sent into space. The scenario seems pretty ordinary, but the results of this mission exceeded all expectations. Have you ever heard the sounds of space? Of course, some of you might argue that a vacuum is completely silent, since sound waves can only travel when there are molecules to transmit the vibrations. Nevertheless, thanks to computer conversion, we can hear the booming rumbles of Venus. The monotonous howl of Jupiter. The pulsating cacophony of Mercury. But these, you could say, are local voices. What does the echo of deep space sound like? Only the Voyagers and the Pioneers have been there, but contact with the Pioneers was lost long ago. A bit later, we'll give you a chance to hear the eerie sounds of the universe, but for now, let's briefly describe the most interesting stages of the 2 probes mission, which is still ongoing. Highly autonomous spacecraft were developed to study the outer planets of the solar system, with the subsequent goal of sending the probes beyond the heliosphere. When organizing the mission, past mistakes were taken into account. For example, Pioneer 10 stopped responding, probably because its radioisotope power source was depleted. By the way, it is assumed that the spacecraft is now heading toward Aldebaran, and this journey will last about 2 million years. Therefore, the issue of powering the probes needed to be given special attention. Both Voyager spacecraft were equipped by engineers with their own thermoelectric generators powered by plutonium-238 and rocket engines, as well as numerous computers and other useful equipment to carry out throughout the entire mission with a plasma complex and so on. Despite minor issues, the spacecraft managed to successfully explore the planets of the outer solar system and set off into the depths of open space. Everyone knows that the boundaries of our parent star's domain do not end right beyond Neptune. The Voyagers, carrying golden records with the sounds of Earth, volcano eruptions, the noise of wind, a baby's cry, still had a very long and difficult journey ahead of them. Fortunately, the technical capabilities of both Voyagers allow us to communicate with them until 2030. What tasks are the probes currently working on? The main goal of the spacecraft is to study the transition region between the plasma inside the solar system and the area in interstellar space. Both spacecraft cross the first boundary separating our planets from the cold darkness of space, the heliospheric shockwave, several years ago. Voyager 1 did this in December 2004 and Voyager 2 in August 2007. The termination shock is a region located inside the heliosphere. It is here that the solar wind slows down sharply to subsonic speeds as it collides with interstellar matter. It is worth noting that for the first 10 billion kilometers, the solar wind travels at a speed of about 1 million kilometers per hour, and only the presence of cosmic particles is able to slow down this rapid journey. After the aforementioned milestone, the spacecraft faced the next notional boundary, the Heliopause, which, according to scientists, they were not expected to reach until 10 years after crossing the termination shock. Therefore, most likely the event has already taken place. The Heliopause can technically be compared to an airlock, where the pressure is equalized when astronauts go out into open space. It is here that the velocity parameters of the solar wind and the interstellar medium reach acceptable values, and partial mutual assimilation of matter also occurs. In fact, there have been debates about the nature of the Heliopause for years. At one time, it was believed that it was located not far from Jupiter's orbit, but Voyager 2 dispelled this myth. Since no one knew where this boundary was, astronomers doubted that the probe would cross it before it stopped working. But the encounter happened before that occurred. Officially, Voyager 2 crossed the Heliopause in 2018, and it turned out that it is 120 times farther from the Sun than the Earth is. Thanks to the measurements that both probes periodically sent, it was possible to find out that the heliosphere is quite elastic. During periods of solar activity, it inflates like a balloon and then returns to its previous size. What other discovery did Voyager 2 make? In 2020, its plasma sensors detected one inexplicable peculiarity. The farther the probe moves away from the Sun, the greater the density of interstellar space becomes. Perhaps the particles sharply decrease as they approach the heliopause and pile up on each other like a snowball. There is another theory as well. It suggests that the interstellar magnetic field collides with the heliosphere, creating a kind of corridor between the heliopause and the rest of space. By the way, according to measurements, interstellar magnetism, although 64,000 times weaker than Earth's and only 7 microgauss, is still able to exert a certain pressure on the heliosphere. In any case, the question of increased matter density remains open. Scientists still have to find an answer to it. Is there a danger of destruction for both Voyagers under such conditions? Theoretically, yes, because according to common hypotheses, between the bow shock wave, the so-called Rubicon, when transitioning into the absolute vacuum of space, there is another region filled with hot hydrogen. Scientists have called it the hydrogen wall. The hypothetical bow shock wave is located at a distance of 230 astronomical units from the Sun, and the Voyagers still have to cross it. Although many astronomers consider this supposed boundary to be a mere fabrication. However, let's get back to the Voyagers. Where are they now? The first spacecraft crossed the boundaries of interstellar space back in 2012. Its sensors detected an increase in galactic cosmic rays and later a sharp decrease in solar wind particles. This data serves as convincing evidence that the probe is finally leaving the heliosphere. It was at this location that the spacecraft recorded the strange sound, a monotonous hum interrupted by a piercing whistle. It's unclear what exactly causes the eerie moans, but they definitely give you goosebumps. Some astronomers claim that the sharp whistle is probably caused by regular solar flares reaching the edges of the heliosphere. Voyager 1 overheard all of this in passing, since its journey is not yet over. It will take about 40,000 years, and it will pass by the red dwarf Gliese 445, which is slowly approaching the Sun, and will continue to wander forever through our galaxy. But what about Voyager 2? It's also flying somewhere in the darkness of space. As already mentioned, 14 years ago, the probe successfully crossed the heliospheric shock wave and passed the heliopause. Thanks to the data obtained from Voyager 2, it was shown that the heliosphere is not a perfect sphere. On the contrary, it is a flattened oval with its northern boundary farther from the Sun. Were there any anomalies in the information transmitted by the probe? Yes, there was one discrepancy. Scientists expected that at the boundary of the shock wave, the temperature would be much higher than inside the heliosphere, but that didn't happen. To be more precise, it was hot, but not as much as astronomers expected. The question is, where did the discrepancies come from and where did the extra energy go? So far, all of this remains unanswered. The second Voyager is now about 20 billion miles from Earth and is steadily heading toward the Oort cloud, which it will reach in 3 centuries. And to fly through this spherical region, it will need at least 30 millennia. It's a pity that we will never find out about it. The half-life of plutonium is almost 90 years, and the spacecraft are already down to 40% power or less. Both spacecraft, launched a month apart, are now hundreds of astronomical units from the Sun and have no intention of stopping. They are headed for encounters with stars, wandering planets, lonely comets, and clusters of asteroids. Thanks to the Moody probes, we now know what the emptiness of the cosmos sounds like. We have empirically confirmed the existence of the heliosphere, which protects our planetary system from the aggressive effects of galactic rays. When we hear the abbreviation UFO, many of us immediately think of REN TV. But is it really impossible for uninvited guests to come to Earth? Or for them to permanently observe us from a safe distance, like in Stephen King's novel, Under the Dome? Is there any real evidence of such contact or the existence of intelligent life? If not, then why was the SETI project created in 1959 to search for extraterrestrial intelligence? And why is it still ongoing? Unfortunately, it must be admitted that when it comes to UFOs or evidence proving the existence of extraterrestrial intelligence, most eyewitness accounts are either fake or show clear signs of psychological disorders in the respondents. For example, the use of hallucinogenic mushrooms sometimes produces astonishing results. However, things are not so clear-cut. Let's start by mentioning the successes and failures of the SETI project. Frankly speaking, since the founding of this organization, there have been far more failures and disappointments than positive news. The most notable positive news is the famous WOW signal, received in 1977 using the Big Ear telescope located in Ohio. During the detailed analysis of this radio message, which suspiciously resembled a greeting from extraterrestrial civilizations, hypotheses were proposed, each one more bizarre than the last. The main ones were as follows. The signal was transmitted from a very distant device operating on the principle of a beacon. There is also a theory that the strange message was received from a passing alien shuttle. Be that as it may, in almost 45 years, SETI specialists have not recorded anything similar to the WOW signal, which suggests the radio message may have an earthly origin. For example, it could have been a reflection from a piece of space debris near our planet. But then the question arises, how was the mysterious signal detected on a reserved frequency that is not used by any other radio transmitting equipment? There was also a theory that the Big Ear telescope picked up radiation from a comet, but it was immediately disproved. No such object was within range of the observing equipment at that time. In 2003, there was another signal, a candidate for artificial origin, detected by the SETI project's equipment. The signal was recorded at the same frequency, 1,420 MHz, and repeated 3 times, each lasting about a minute, with its source located between the constellations Pisces and Aries. Later, astrophysicists expressed skepticism, claiming that it was either a malfunction of the equipment or background noise coming from some distant cosmic phenomenon. Given all that, is there any real benefit to SETI's search efforts? Overall, the scientific community is somewhat condescending toward this project, though still generally favorable. It is not funded by the government. As a rule, it survives on charitable contributions. Moreover, there is still no scientific program for detecting UFOs. All searches are limited to scanning space or sending out signals chaotically. The question of whether it is wise to so persistently spread information about the existence of intelligent life on planet Earth was discussed in one of the videos on our channel, which discusses the original and informative dark forest theory. In short, some members of the scientific community believe that sending out signals could actually threaten the safety of our civilization. And perhaps that is exactly why we still can't catch a signal from another civilization. Other intelligences simply don't want to be discovered. However, for example, astrophysicist Alexander Panoff, one of the active participants in the project, is skeptical about this theory. Because if we take human civilization as an example, besides sending signals for possible extraterrestrial life, we unintentionally give many reasons to be discovered. We are a noisy planet. Airfield radars, space debris radars, all these objects continuously emit signals in all directions and can be detected. Next, Panoff develops this theory by asking the question, according to the dark forest theory, whom are we afraid of? We are afraid of those who can come to us and conquer us. In other words, those intelligent beings who are capable of interstellar travel. The level of development of such a civilization must be at least of the second type, according to the Kardashev scale. This means that such a civilization uses the energy of its entire planet, as well as the energy of the star it orbits. In his opinion, for exploring space, it would be reasonable and energy efficient for such a civilization to build an entire army of flying saucers about 30 kilometers in diameter, which would allow it to scan the cosmos. At the same time, our radars are capable of detecting such a saucer from a distance of several thousand light years. Thus, the more advanced a civilization is, the harder it will be for it to remain unnoticed. And now, let's try to answer the question, why, when it comes to UFOs, does it always imply the presence of extraterrestrial intelligence? Can the discovery of technological debris of unknown origin be considered an unidentified flying object? An interesting note comes to mind here. Experts discovered similar artifacts even in the pre-space era, when there was no stable ring of debris around the Earth. During this period, there were multiple recorded falls of meteorites of clearly artificial origin, which cannot be attributed to technological debris accumulated by our civilization. After all, at that time, no such activity was taking place in Earth's orbit. How can such cases be explained? Official science remains silent for now. What are the main issues in searching for and interpreting UFOs? The main issue is that we have absolutely no idea what unidentified flying objects actually look like, so we often mistake objects and phenomena of earthly origin for them. This issue is closely linked to the successful search for extraterrestrial intelligence. And in this case, no one can clearly define what properties the objects we're searching for actually have. And besides, why did we suddenly decide that some civilization dreams of revealing itself by sending signals and launching spacecraft, or is persistently trying to settle new territories by capturing them? Probably, we draw such conclusions based on the troubled history of human civilization. In fact, the question of detecting UFOs is much deeper than it seems at first glance, and it raises questions for cosmology. If unidentified flying objects exist, then there is a high probability that they may belong to some intelligent world. From this, we can conclude that the universe is full of life. But again, what makes us think that this life is similar to ours? Supporters of the panspermia theory believe that comets are carriers of the spores of life. Therefore, it is likely that all biomes are built from the same nucleotides based on the familiar carbon foundation. Furthermore, the scenario for the development of such worlds may follow a different path, but overall similar features will remain. That's why we search for UFOs as evidence of intelligent life in the universe, which likely has similar aspirations. Actively observing, monitoring space, sending their craft to all corners of the cosmos, depending on their technological capabilities, conquering new territories, and so on. Nevertheless, it's unclear why there is still relatively little evidence of UFOs appearing near our planet. If we set aside theories that intelligence agencies are carefully hiding artifacts from the public, the situation in this regard is rather depressing. However, there are still precedents. For example, in the United States from 2004 to 2021, there were 144 recorded cases of various UFO sightings that still cannot be explained rationally. A group was even created in the Pentagon to study such phenomena. And quite recently, in June 2021, U.S. intelligence agencies published a report analyzing UFO sightings by American military personnel. It states that intelligence was unable to identify the objects, and the version that they were UFOs is recognized as one of the possible explanations. Data on UFO sightings around the world have been systematized since the mid-20th century, but ufology has never been elevated to the status of a science, so most research is conducted almost entirely on a voluntary basis. People also often mistake for UFOs the chemiluminescence of industrial emissions into the atmosphere, auroras, weather balloon flights, unusually shaped clouds, rocket launches, and even the full moon. What will happen if we actually receive a signal from an extraterrestrial civilization or discover an unidentified flying object that clearly proves such a civilization exists? Wouldn't that be the collapse of the world we're used to? After all, once people find out we're not alone in the universe, they might stop taking care of Earth altogether, since they could always escape to some other planet. As the saying goes, home is where you're happiest. However, at this stage, it's more relevant for us to turn to the technical side of the issue. If an extraterrestrial civilization is similar to ours, its messages will contain basic information about physical laws, culture, history, and other aspects of how their society works. Earth has sent this kind of information about us into space at various times. So, we've received information from our distant neighbors. What should we do next? The messages are deciphered, which can take years or even decades, then interpreted and ideally integrated into the cultural sphere, a kind of cosmic internet. This global network will inevitably emerge over time, provided that signals come from different civilizations across the universe. Then useful information can be systematized in the form of a virtual encyclopedia, expanding our understanding of the macrocosm and its inhabitants. Imagine a cosmic Wikipedia. Does that seem naive or unrealistic to you? Only history will reveal where the truth lies. By the way, receiving multiple signals from advanced civilizations similar to ours, built on a common foundation, would be undeniable proof of the panspermia theory. That is, the fact that life in the universe spreads through spores. And finally, should we respond to a signal coming to Earth from outside? Of course not, because it's absolutely useless, considering the enormous cosmic distances and the limitations of our transmission methods. We live in an era when science is pushing the limits of what it can do, and very soon, empirical methods may hit a dead end because of gaps in our knowledge or inadequate technology for conducting experiments. Remember that scientists are more willing to consider things that are reproducible, that can be checked and tested. In this regard, the discovery of UFOs or signals from more advanced civilizations would become a stimulus for the further development of science here on Earth, and a cosmic internet containing information about the diversity of worlds would serve as a treasure trove of new knowledge. Should we shut down the SETI project and discard the opportunities to study artifacts that have even the slightest connection to unidentified flying objects? That would be, at the very least, foolish. By rejecting information that we are not yet able to explain, humanity would resemble helpless blind men running into a solid wall. Do you agree with this statement? Share your thoughts in the comments, send the video to your friends, and don't forget to subscribe to the channel if you haven't done so yet.